Hello, students. Jumping into those mathematical connections. Math connections 6.1. Let me turn this off here. Leave that. So 6.1, I've got 1 to 2, 4 to 13, and 15 to 22. So let's take a look and see what we're going to do. So 1 to 2. So 1 to 2. Oh my goodness. This was on Below Deck. Because somebody said, okay, I'll see you at 7:15. And the other girl showed up at 7:25. She's like, yeah, a quarter. It's like 25 cents. So she showed up at 7:25, which is 10 minutes late from what the other gal was wanting. They got into a huge argument. So I was like, you know what? Reality TV, we're going to make sure you're here in the homework set. So yeah, 15 minutes is 1/4 of an hour. 25 cents is 1/4 of a dollar. Aren't those fourths or quarters supposed to be equal? It's a quarter. Um, and then we'll leave that. So 1 to 2 in two different fourth grade classes, 1/3 of the members are girls. Does each class have to have the same number of girls? What a great question. Okay. They each have a third. What's the issue? So there we go. There are some other picture ones that you may or may not want to go ahead and do, but I'm going to go and jump to my next part, which was 1 to 2, 4 through 13. So I skipped 3. Draw a Venn diagram with relationships among natural numbers, whole numbers, integers, and rational numbers. So we've already talked about how every natural number is a whole number. So that would be kind of a nested piece, like one circle inside of another circle. And maybe there are other relationships like that. Explain why the fundamental law of fractions n must be 0. Yeah, how come you can't have 5 times n over n? Why can't I just put n equals 0 and have it work out? Nudge, nudge, wink, wink. Think back to division. The rectangle here is made up of x's. It is 2/3 of a regular rectangle made up of x's. Draw the other rectangle. So this is where, again, sometimes students read this wrong because they're reading very quickly. It is 2/3 of a larger rectangular shape. So see this right here, this is not my whole object. Somewhere there's something that is a whole, and this piece is 2/3 of that one. And so you have to draw the other rectangle. Okay, so kind of talk about how did I get that when all I know that I have 2/3 of what I'm supposed to have. Explain how you could use these shapes to show 4/3 and also 4/6. So the same shape could be used for that. Oh, this is the pizza question. So I already mentioned that in one of the other homework pieces where it's, hey, I've got a 12-inch pizza and an 18-inch pizza. We get 8 equal sized pieces and you eat one from one. And you say, oh, well, then I must have eaten 1 and 2. That's 2 pieces out of 16. So, oh, yeah, I ate 1/8. Did you eat 1/8 or not? How would you know 1/4 of the combined area of the 3 squares shown? There's actually quite a few different ways to do this, so I'm going to let you come up with a way that works for you. How would you get 1/4 of the combined area of these shapes? And next is 0/6 in simplest form. Remember what simplest form means. Link back to the definition. Simplest form does involve that GCD. A student writes 1/15/53 is less than 1/3 because of this, and another student crossed out the 5s and they are equal and said, aha, what is the issue? Love that canceling, right? 15/53, I'll cancel the 5s off and I get 1/3. And you might say, oh, you can't do that, right? But what if a student had this problem? 16 out of 64. Now you type this into your calculator and hit that fraction button, guess what? You get 1/4. So if a student came along and crossed off the 6s here and said, oh, I get 1/4. Does that mean they're right? Because they got the right answer? What an interesting question, aka test question sometimes. So let's see. Let's see here. There are no numbers between 999/1000 and 1 because they're so close together. How do you respond? Cut a pizza into 12 pieces, and that's more than cutting it into 6 pieces. This is student thought processes. Cannot show 3/4 of the following faces because some are big and some are small. Okay. What else do we have? Two positive numbers. One is greater numerator. The one with the greater numerator is greater. So they're trying to come up with their own rule that might be quicker than the things that you might have talked about. Love it. Okay. Shaded circles. Does this represent 2/3? And the student says, hey, it can't represent 2/3. There's 10 circles that are shaded, but 2/3 is less than one. Right? Let's see. How far did I go? To 15. And then what did I say? 15 to 22. Okay. Oprah. Hey, she's comparing. She says the one with the larger denominator is smaller. Okay. How do you respond? And be thinking about this. It's possible, again, that the student is correct sometimes, right? The test questions I give you are always, sometimes, and never. So a student comes up to you with something, be thinking, is this always true? Is it never true? Or is it maybe sometimes true, and maybe I can see why they made their mistake? Let's see. If two fractions have the same numerator, is the one with the smaller denominator the bigger fraction? Let's see here. 1/3 is halfway between these because, well, I have no idea why, but just says it is because maybe it makes a nice sequence of 2, 3, 4. How do you respond? What do you think? Is it actually halfway between? How would you demonstrate that it is or is not? And lastly, I got to go to the next page for 22. So let's jump over to number 22 right at the top. Carl says the shaded portion shows 6/8. Callie says it shows 6/4. How can you help? Who is correct? Is one of them correct? Are they both wrong? Are they both right? And what would this mean if you were kind of explaining this in your own classroom? So those are the big pieces here for the MCs. A lot of it is about the concepts. There's not a lot of doing, but you saw a lot of student questions in this because when you deal with fractions, you're going to get a lot more student questions than you do when you deal typically with whole numbers. And oftentimes that is a result of students also going home and trying to get support and assistance from the folks at home who probably also feel very comfortable with whole numbers, but not as comfortable with fractions. So this is where you tend to see quite a few more issues arising in your classroom than you do when you had just whole numbers as you go forward. All right, off you go.